This is a TZXDuino kit I bought from Zaxon about 7 years ago. It's the very first version with a small error on the board. It's an Arduino based solution to turn digital tape files into audio for classic computers like the ZX Spectrum and MSX. And we're going to build it, program it and test it right now.
Mark fixes stuff. This video is sponsored by PCBWay. You can get an instant quote on a variety of services, or browse a library of talented makers' designs, add them to your cart and have them delivered directly to your door.
Components wise, we have a 16x2 LCD matrix display panel, a full-sized SD card slot showing the age of the kit somewhat, an LM386 audio power amp and socket, 5 momentary tactile switches, an Arduino Nano clone, an IC2 backpack for the LCD display, 4 hex standoffs with screws and insulating washers, a couple of rows of header pins for mounting the Arduino to the PCB, a 4-way strip of ribbon cable, a bunch of resistors and a ceramic capacitor, and a couple of electrolytic capacitors. Okay, so here's the board, and before we start we need to clean off any dust or fingerprints as usual. Trusty PCB holder at the ready, and a generous sploosh of 99.9% pure isopropyl alcohol to clean any grunge, grit or grease from the green PCB. Cleaning your board is a very important part of any project, and we can prevent soldering difficulties later. Now remember I said there was a mistake on the board? Well, this connection shouldn't be connected and we'll need to fix that. Using my Dremel and a cutting bit, we can sever the track. That should definitely do it, but it's best to check for continuity with a meter. Nothing connected here, which is perfect. Popping on a bit of liquid flux, I prepare to solder the SD card socket. These can be a pain because the metal shielding quickly transfers the heat away from the iron, and cranking up the temperature could melt the internals of the part. The solder goes on a bit blobby, but it makes a good connection and will work for our purposes. With the shell of the card reader fixed firmly in place, we move on to soldering the data pins. These are a lot easier. Well, maybe not this one. Resistors R1 to R3 are 1.8 kΩ parts. Let's install those next. My resistors have 4 stripes: brown, grey, red, gold. You might have more stripes of different colours. There are a few variations. If unsure, just check with an online calculator. Let's solder these in. A bit of liquid flux. And with our soldering iron set to 330 degrees centigrade, we touch the leg of the component and the solder pad at the same time. I really need to save up for some better solder. With the joint soldered, we can trim the excess component legs, or leads as they're called. You should wear eye protection because these little death javelins like nothing more than blinding humans. Resistors R4 through 6 now. These are 3.3 kilo ohm resistors and are marked orange, orange, red, gold. Again, your parts may be different colours to mine. Carbon film resistors are a fixed value component and consist of a small ceramic tube around which there's a spiral of carbon film. The width and amount of turns in the film determine the resistance of the component. A thicker path with less turns offers lower resistance than a thinner path with more turns. With those in place, it's time to install R7. R7 is a 10 ohm resistor marked brown, black, black, gold. Resistors are important because they restrict the flow of electrical current and lower voltage. Without them, the more sensitive components would burn out. A socket for our audio power amplifier is next. This is to make sure that the audio output level is high enough to be picked up by the computers. The Smurf poo holds the socket in place whilst we solder. And the solder fixes the socket well. Next, the jack socket that will provide the output connection for our TZXDuino. And a couple more slabs of the blue goo will hold the part in place. A wee drop of flux. And some more solder to mount the 3.5mm jack socket to the PCB. Jack socket done. Just to make sure all the internals are fine, we dry fit a 3.5mm jack plug, nice and tight. C2 is next. It's a ceramic capacitor and they don't have a polarity, meaning you can insert them any way around you please. This part is rated at 47 nanofarads, and after a little more flux, we solder this component into place as well. With C2 installed, we turn our attention to capacitors C1 and C3. These are both electrolytic capacitors and have a polarity as indicated by the plus markings on the board. C1 is a 10 microfarad part, rated for up to 16 volts. The longer leg on a capacitor denotes the positive lead that needs to be installed in the hole with the plus sign. C3 is a 220 microfarad part, also rated for 16 volts. Again, the longer leg goes into the positive hole. Let's solder these into position. Electrolytic capacitors use an ionic fluid called an electrolyte to charge and discharge across the legs of the capacitor, known as the anode, which is positive, and the cathode, which is negative. Because capacitors charge and release energy quickly rather than letting it flow freely, they're great for smoothing noisy power inputs or filtering out electrical interference in a signal. These 5 tactile switches are next. They must be placed in the correct way around as well, but fear not because they're slightly rectangular and can't be put in sideways. More flux, then solder time. I hope you're enjoying this video. This channel is patron supported and patrons enjoy exclusive behind the scenes videos and ad-free video releases. If you'd like to help me make more videos, please visit patreon.com/markfixesstuff for details. It's really easy and every pledge of support, large or small, helps me on this YouTube journey. And you'll even get your name in the videos. Okay, it's now time to install the brains of the unit, the Arduino Nano. The Nano is to be soldered into the board using 2 rows of 15 header pins. To make it easier to keep the pins straight while soldering, I like to use a simple solderless breadboard. With the header pin rows spaced out, it makes it really easy to solder the pins into the Nano first. A solderless breadboard is a way of hooking up small prototype circuits easily. The holes are connected in a grid formation with positive and negative rails that run down the right and left hand side. Back in the early days of electronics, makers would hammer nails into small planks of wood resembling breadboards, then wrap their components around them to make a circuit, and that name has stuck even today. Well, that certainly made life easier than soldering wobbly pins. Before we solder it into the project, let's sort out the LCD screen. This is a 16x2 matrix screen. The 32 characters in total are activated by powering these pins directly, and this is called an I2C or IIC backpack. It takes the information that the Arduino passes it and interprets it to signals to turn the pixels on and off. These pins aren't ideal, so I think I'll remove them for this build. A quick blast with a desoldering gun, and the 4-pin header is soon removed. Now, I'm not perfect and I made a bit of a boo-boo here. Originally, I used some high quality 22 AWG hookup wire. They're nice quality and solder easily. Next, I soldered the backpack to the LCD display. And it was all going so well, until I found that the 22 AWG wires were too thick to go into the TZXDuino PCB. So here we are with some equally nice but thinner 30 AWG hookup wire to redo those connections, hopefully without needing to desolder the I2C backpack from the LCD. I'm also going to make them nice and long this time, so that I can easily position them when the screen is in place. Having a couple of boxes of hookup wire really makes life easier. Gone are my days of scavenging wire from old cables. Also recommend grabbing a cheap wire stripper. Gone are the days of using me teeth and spitting out ends across the lab. Whilst not always needing fresh new wire, it's really good practice to tin or coat the ends of your wires before soldering them into the boards. Metals can be contaminated, making soldering a pain, so if your wires are pre-tinned, you've dealt with any problems before they've happened. The smoke here is flux, burning any contaminants off of the surface of the wire. All that's left to do now is to awkwardly poke the tin wires through the board and solder them into place. Wow, I'm such a professional. End sarcasm. Trimming off the ends of the wires, I think that's actually turned out nicely. At this point I realise I've made the wires far too long, but decide to twist, tuck and forget it ever happened. Let's solder the Arduino Nano to the board now. I quickly give the board a clean with IPA to remove the flux residue. When installing a Nano, look to match the TX pin marking on the board with the TX pin on the Nano. The header pins keep the Nano quite firmly in place, so we'll just go for soldering straight away. Because these pins are quite large, they have a lot of thermal capacity, meaning they can take a while to heat up. I generally don't like to ramp up the temperature higher to account for this because it can damage the PCB. Sometimes I'll go back to a pin and rework it to make sure the solder has flowed into the joint correctly. This can upset some Internet Pro solderers, but it works for me. Feel free to complain below and drive up my video engagement statistics. The LM386 audio power amp just needs to be pushed into the socket. And now we get to solder that screen into the board with its mega long cables. It's pretty much solder like to like, with VCC on one side meaning 5 volts on the other. And yes, I could have shortened the cables at this point, but I'm not going to lie. I was getting a bit knocked off with constantly fluffing things up. Ground and 5 volts, or VCC, power the LCD whilst data is transmitted through the serial data line, SDA, and controlled by the serial clock line, SCL. The I2C protocol is very robust and can address well over 100 devices with just the SDA and SCL lines when used in 7-bit mode. So a bit of extra wire isn't going to matter at all. Next, it's time for Meccano. Or at least screwing the 4 posts onto the screen and mounting the board. These nylon washers are for the LCD side. I don't think it's really an insulator because the holes are plated inside as well. It's more for a bit of grip, I think. Just going finger tight at the moment, and then we can screw them hard with a proper tool later. Once the legs of our LCD tableau are installed, we can screw the underside of the legs to the shield PCB. Lining up the legs shows they're a perfect match. Terry and Dave guard the screws whilst I'm working. And finally, our unit is complete. Let's peel off that protector. The unit is powered and programmed by this USB port, and we're going to program it right now. With the Nano program memory blank, we just get a blank screen. So let's go through how to program the device. First, we'll need the Arduino IDE or Integrated Development Environment from arduino.cc. You can get a Windows 10 app, but I prefer to grab the executable instead. The project is supported by donations. You can download it for free, but even a tiny donation helps keep it in development. I've already donated, so I'll just download this time. Once the software has downloaded, we can install it in the usual manner. It's okay to accept the defaults and click Next. Then clicking Install will set the installer chuntering off to do its thing. If you click the Show Details button, you'll be able to see what's being installed and where. It might take a moment, but eventually it will install. Next, we need to head to our duitape.blogspot.com to grab the latest TZXDuino firmware. At the time of this video, the latest version was 1.17, with it being a quick patch of a bug introduced in 1.16. We click the download button. Thanks to Duncan, Sadken and everyone else who's had a hand in this fabulous project. Once the firmware is downloaded, we need to extract it. And yes, that's an actual registered version of WinRAR. You can do that, you know. When extracting the files, it's important to put it inside its own properly named folder. The folder would be called the name of the archive. This is correct, so extract it and close the WinRAR window. Now we need to start the program and do some initial one-time setup on the Arduino IDE for the TZXDuino. Ignore what I have on the screen here and use the file menu to open an Arduino sketch. Then navigate to where you extracted the firmware files. The file we need to open is the one with the version number at the end, 1.17. From the Tools menu, click Manage Libraries. We need to add 3 libraries that the TZXDuino firmware uses. It's easy, but there is a slight quirk which I'll explain. Mine are already installed. I'll show you what they are. First is Liquid Crystal I2C. Install the latest version. Then we need SDFAT. Here is that oddity, because the latest version won't work. Duncan is aware of this, but we can just use version 1.1.2 without a problem anyway. Lastly, we need Timer 1. Again, just search for the library in the top bar and install the latest version. With our libraries installed, we can verify that our sketch compiles and is ready to be sent to the Arduino. This low memory warning is fine. It's not an issue for this project. Now we need to connect to the physical Arduino. The IDE defaults to COM1, but this is never correct. So let's set the board type and the port of the connected device. Under Tools, Board, we change the board type from Arduino Uno to Arduino Nano. That's then reflected at the bottom, but still on the default port. If we select Tools, Port, Get Board Info, we can test the connection. Obviously it fails. Next we go Tools, Port and select the correct port. You can find this in Windows Device Manager, but a quick tip is that it's usually the last port added, the highest number. Here it's COM10, and going back to get a board info shows a connection, but there could still be a small gotcha. Let's try uploading to, or programming, our actual Arduino now. The sketch compiles and seemingly starts to upload, but takes a very long time. Then we get a nasty red error message. But fear not, because many of the clones on the market use an older style bootloader than the new IDE is expecting, and it's an easy fix. Simply select Tools, Processor, and switch to the old bootloader version. Again, this is reflected in the bottom corner. Let's try again. The sketch compiles with the usual low memory error that isn't a problem. And very quickly uploads to the program memory of our actual Arduino. With the firmware on our TZXDuino, it's a case of cycling the power by unplugging and repowering the device. And it's working, but asking for an SD card. The button functions are up, down, play pause, stop and menu. My card is FAT32 formatted and simply has some directories on it called ZX Spectrum and ZX81 containing various TAP and TZX files. Testing on my ZX Spectrum, I've connected the output of our device to the ear socket on the computer. Loading works great, and the nice thing is that there's a percentage meter. Loading is in real time, so I've edited it down a bit. These loading screens are something you really miss when using an instantly loading div MMC device. The 16:2 screen is really bright and clear. I'm glad my janky soldering paid off. And as we get to 99%, will it work? And the answer is yes. I also loaded up the trapdoor, which also worked fine. Then switching to a newer title, I loaded the amazing Dreamwalker game. You must try this if you haven't already. And that's how you build a basic TZXDuino. This is an older version, but there's a link below to the newer version with motor control, which you can get directly from PCBWay. Massive grateful thanks to Zaxon for supplying the files. And also a massive thanks to my amazing patrons who make my videos possible. Here they are on the screen right now. And you can join them in helping me make more videos at patreon.com/MarkFixesStuff. Thanks for watching this Mark Fixes Stuff video. I definitely think you should watch one of these now. Bye!